Assalamualaikum and greetings. My name is Samutafi Ariza bin Mano and I would like to present my project which titled Iris Recognition System using Daugman Algorithm with Raspberry Pi. For introduction, iris recognition is one of the biometric identification methods that are implemented today. It operates by identifying an individual identity based on the iris pattern of the individual. It was first suggested by Dr. Framberg in 1939 and then it was first successfully applied by Dr. John Daugman in 1990. It is recognized as one of the most precise iris recognition that are used today. The problem statement of this project, implementation of traditional method for identify an individual identity have a risk of authentication tools to be forgotten or lost due to human nature behavior. Certain biometric features are strictly related to the certain human body structure that are prone to change over time, such as face recognition. The traditional system is particularly risky since some of the methods require the user to perform certain physical activity to authenticate the system during this pandemic of COVID-19. The objective of this project is to develop an iris recognition system using Raspberry Pi to implement the Daugman algorithm into the system and to test the real-time iris recognition system. The slide shows the structure of an eye. Iris is the colored ring-shaped region that are located between pupil and sclera. It contains a unique and a complex random pattern that are epigenetically differ for every person. It also has a stable or unchanged structure throughout life, which provide a good biometric approach. This is the block diagram of the system. Pi node camera will be connected with the IR LED with the Raspberry Pi 3. Pi node camera will be used to input a real-time image for image acquisition and recognition, while IR LED module will be used to provide illuminance to enhance texture of iris pattern. For commercialization potential, it can be used for securing financial transaction, whereas e-commerce and financial institution for identify authentication, management system by maintaining time and attendance record, facility access control of controlling the access of fees, laboratory and factory, national border control for security screening of control and management of border by authority. Contribution. The contribution of this project is to provide a low-cost iris recognition system to provide an iris recognition system with low output of FAR, which unauthorized user accepted and FRR, authorized user rejected. The third one is to provide an alternative of contactless biometric approach for integration with any system, especially during COVID-19 era. For prototype demonstration,
there are three main functions, which is to capture user iris, train dataset, and execute iris detection. For capture user iris, are used to perform image acquisition on the eye of newly user. So as we can see, after it completed acquired the new eye image, it will provide a new user ID, which is 109. And after that, we can stick to performing a training dataset to training the newly acquired input image. Take some time, and after that it will show a training successful with the total time generated, and we can proceed to execute eye detection for recognition process. So the camera will detecting an eye image and performing recognition based on Daugman algorithm with using a multiprocessing. So as we can see, there are some lagging. So it shows that the system are performing at full capability, and it will show the result, which is authentication is successful. So it detecting the user 109.
for model evaluation, there are two types of database are used with combination of real eye image captured. F-metric are selected as main metric for the model evaluation because it gives a better measure of incorrectly classified cases. Optimal threshold are obtained from maximum value of F-score for tuning. Cassia Iris V1 have a high percentage value of F-score recorded at 94.8 compared with the MMU database, which gain a value of 41.7. The major factor of differences output between the database is the quality of iris image provided. One of the testing method is conducted based on the FAR and FRR, whereas it consists of 100 subjects for both database. 50% allocated for authorized user and other 50% for unauthorized user. Results show Cassia RV1 has a lower FAR and FRR value compared with the MMU as expected. Thank you.